Yeah, my name is Martin. I'm a member of Ruby core, and I'm one of the maintainers of the Ruby OpenSSL extension, and as of last year, I'm a freelancer. I'm also from Germany, and I want to talk about cryptography in general, but in particular about Krypt. So what they tell you is that cryptography is hard, and it's really hard to do it right, and you should probably never even do it, but sometimes you have to. And if you do it, this is what happens. You'll get sad pretty quickly because it's just so hard to do. And apparently, there's just a few people who get it right, and apparently Snoop Dogg is one of them. But there's not a lot of people like him, right? So the real question is, if cryptography is hard, do crypto APIs have to be hard too? And there's really two opposing forces here at work. There's one camp where programmers just care about their end result being secure, so they don't care about the underpinnings of cryptography. There's another camp, people who probably write crypto code every day, and they want to have full control of all the parameters, so they actually care about the details. But let's face it, in everyday development, security sucks. Nobody likes to do it, because if you do it right, nobody notices. If you do it wrong, that's the only time you notice it. And yeah, nobody wants to have security around. And this is something that's never going to happen. You're not going to go home to your wife or your husband and tell them, oh, God, I wrote crypto code. Not going to happen. And that's why I claim that cryptography and security is the Jar Jar Binks of software development. So it's a huge pain, but eventually we have to face it. You know, you can't just overlook it. And it can be a real bitch, you know, stab you in the back the minute you turn around. And that's why I also claim that it's also the Joffrey of software development. So I believe that good design is making complex things easy. And we have a lot of examples where this has already happened. So cryptography is not the only thing that is hard to do. For example, databases. We have active record for that. Threads are hard. OK, we have STM and actors for that. And as users of Ruby, we know that memory is hard, but we have a garbage collector for this. And the underlying principle is that we, as developers, don't want to be bothered with the details. And we don't want to think about it. We just want to use it, and it should work. So why hasn't this happened for cryptography? For one thing, experts, they need full control. As I told you, they need those parameters and details. And this causes a conflict, because everyday development, you don't want to care about the details, but experts do. So we have two opposing forces here at work. There's, on one hand, abstracting things, making things easier. But there's also the danger of oversimplifying things, because you could abstract it to a level where it's not possible anymore to do things actually that you wanted to do. So I believe, especially in cryptography, there's no golden middle. So there's no one true way that would fit all. And this is why in the past we have had libraries targeted at the different camps. So if you're in the full control camp, then you can use something like OpenSSL, the Java security libraries, and similar libraries. There's actually a lot out there. If you're in the other camp that doesn't really care about security, just wants the thing to be secure, then you have a lot less choices. So Kisa was one notable attempt to provide such a library, which is easy to use. And maybe Salt, RB Salt, and Lipsodium, which is a more developer-friendly version of Salt. So they're in that camp. If we already have something that makes our lives easier, so why don't we just use it and be done with the whole problem? Well, first of all, there's the people that need the details, as I've already told you, and there's legacy applications. So if you're dealing with an application from the 80s, then chances are high that you actually have to use algorithms and protocols that are considered broken by today's standards. So I claim we need both. We need full control if the situation requires it, and we need, if you're lucky enough to be in a position where we're in control of all the parameters, then we should use something that is secure and easy to use. So why is it that we can't have both? We had this not really revolutionary idea of, just combining the two things. So why not combining full control and easy-to-use API in just one library? Sorry. And that's where Krypt entered the picture. So Krypt, you might be asking yourselves right now, what is Krypt? What does it do? And let's start at the beginning. Who's working on Krypt? There's 5 people at the moment. There's Nahi, Vipul, who worked on Krypt on last year's JRuby Google Summer of Code. There's Bruno, there's Douglas, and there's me. And something we're often asked is, will Krypt eventually replace OpenSSL, Java Security Library, or any other favorite crypto library you might have? And the answer is no, it doesn't, because Krypt understands itself more like a framework. So it's a framework that uses existing libraries to implement the core primitives for cryptography. So I claim we can actually coexist together. And simply by wrapping those existing libraries in a common Krypt interface, this is what already gives us this low-level API that makes it easy to use if you know what you're doing, if you need all the details, all the parameters. So examples for this would be digest algorithms, symmetric and asymmetric encryption in the form of ciphers and signatures. And what Krypt additionally does is it adds ASIN1 to the mix. So ASIN1, think of it as some form of binary XML. It's used to define data structures, and it's pretty much the de facto standard in cryptography. So everybody hates it, but it's a standard, so we have to use it. And yeah, it should be easy to use this, because if you want to stay extensible, if you want to implement a new protocol or anything like that, then it should be easy to do this. Now let's suppose you're in the other camp that just cares about writing secure code, but you don't care so much about cryptography. How can Krypt help you there? And the answer is that Krypt uses this low-level API that already exists to implement this higher-level API that is easy to use and secure by default. So you might ask yourselves, what's the big deal about having this high-level API? Because so few libraries actually offer one. Why is this important? And to see why, let's have a look at how things go wrong in practice today. So I have a few examples. The first one is for encrypting data. And this is how it should look like. This is taken directly from the OpenSSL documentation. This is fairly secure. So things to notice here is that the key is actually generated using random, cryptographically secure random generator, and so is the IV. And now let's have a look at how this goes wrong in practice. So the first thing that I often see in the wild is that people actually use some form of textual password. I don't know if you can read this in the back, but yeah, I'll publish the slides later. So people use textual passwords instead of randomly generated keys. And this is pretty bad because it restricts the entropy of the value. So it's much easier to brute force a key like that. Then there's the problem that people don't know which encryption mode to use. So sometimes they use ECB, but ECB is wrong probably in 95% of the cases. And you shouldn't really use that. You should use something like ECB, and if CBC, sorry, if it's available, you should use authenticated encryption modes like GCM. Then if people use something else than ECB, they often forget to use IV, an initialization vector. This is actually needed if you do something other than ECB, but OpenSSL will allow you to omit it because it will have an implicit default. But having a deterministic implicit default actually opens already known vulnerabilities. And so you shouldn't do this. You should always generate your IV manually by using a cryptographically secure random generator. Then there's the API itself that makes it hard to use. So you have to call cipher.encrypt or decrypt if you're either doing encryption or decryption. And this is not intuitive, so this should be implicit. Then there's also having to call cipher.final. This makes sense if you're in a streaming context, but if all you want to do is encrypt one block of data, then you shouldn't be required to call cipher.final. So second example is about storing passwords securely. So first remark, you should all be using bcrypt for this because it actually has the same API to do this. But sometimes projects require that you use PBKDF2, which is an official standard, and so banks and governmental institutions need something like this. And it has 4 parameters, as you can see, the password itself, but also a salt, an iteration count, and the length of the actual output value. So, how does this go wrong? Oh, I'm sorry. How does this go wrong in practice? First of all, something that people often do is they use the password for the salt. And their reasoning is, well, this password is already secret, so why not use another secret value for the salt? So this will actually make it even more secure, right? But that's totally wrong, because what happens in practice is that if 2 people have the same password and you do this, then it will also have the same password hash. So this means that an attacker, just by looking at your database, will already know which users have the same password. So don't ever do this, because it actually defeats the purpose of having a salt in the first place, and it's also much easier to brute force this. Then the iteration count. So we always try to be conservative because we don't want to denial of service our application by choosing an iteration count that is too high, but something like 10 just doesn't do anything. So it should be in the thousands, 10,000s, and not just 10 or 20. And the hardest parameter to deal with is the length of the output parameter, output value. So what should you choose there? And the golden rule is to choose the output length of the underlying hash function, which in this case would be SHA-1. If you choose something that is less than that, then you make it less secure. But if you choose something that is longer than that, then it won't give you any additional security. So you're just wasting time. And again, there's the API itself. So having to call 4 parameters, I always have to look up the documentation myself to get the right order of the parameters. And also, the name of the function itself. Nobody would ever guess that you can actually use this for password hashing. But probably the real problem is that people still do stuff like this. They use digest, probably a broken one like MD5, and all they do is they hash just the concatenation of the salt and the password. So this was something that probably worked 20 years ago, but with today's computation power, this is worthless. And if you still do it, then here's what I have to say to this. So the third example is about certificate validation. This is also a real pain to do. Here's an example of how you'd do it. And the answer is, if you can't read this, you actually don't, because I couldn't fit this on 1 slide. I probably couldn't fit it on 10 slides. And to be honest, it's almost impossible to do this. The reason is that to do it correctly, you would have to do online revocation checks. So you would have to download CRLs or OCSPs to check whether a given certificate is valid or not. The problem is that OpenSSL actually refuses to have any external dependencies. So to download CRLs or OCSPs, you would have to have something that gives you HTTP at least. But since they refuse to have external dependencies, you can't do this. And so I believe this was probably a strategy that dates back 10 or 15 years ago. But with today's dependency management tools, I think behavior like this is really uncalled for. So why not just include something that gives us HTTP? And this has really far-reaching consequences, since everybody who wants to use OpenSSL to do certificate validation either has to use this half-assed validation thing, so it's not done correctly, or if they want to do it correctly, then they have to write their own extension code. And now you can imagine if 1,000 projects or applications do this, how often this will go wrong in reality. And I clearly believe that it's the responsibility of the library to do this correctly. So now that we've seen the bad examples, let's look at how Crypt tries to improve those things. And here's what I believe this API, this higher level API should look like. And the intention here is that you actually are allowed to simply write down your thoughts. So there's no unnecessary parameters. You just express your intention. And what's your intention if you want to encrypt something? Well, first of all, you want to establish a key between both parties. So there should be a method that allows you to do that. Next, what you want to do is you want to encrypt some data. So why not just write that? And you do the same thing in reverse if you want to decrypt it. Then there's password hashing. So what do you want to do there? Well, you want to hash a password. So just write that. And if you want to verify an incoming password, if you want to verify it against an existing hash, then just write that. Verify hash against password. And there's another principle that I believe is important here. So a lot of libraries in the past have treated validation with a Boolean function, returning true if validation was okay, and returning false if it failed. And I think this is really dangerous because sometimes you forget to check for that parameter, and this is dangerous because even if validation failed, your code will just go on acting like everything was fine. So I think the only sane thing to do here is raise an error if validation failed. And the same thing for certificate validation. What do you want to do there? Well, you want to take your certificate and verify it. There's no need for additional optional parameters. Just tell me if this thing is valid or not. And if you actually want to customize the process, then you're still allowed to do so. But by default, you can use something that is very easy to use, and it will just work. So again, this is the principle of that you don't want to think about the details. You just want to use it, and it should work. And this is pretty much convention over configuration, just that in this context, it's called security by default. So you have something that is easy to use, needs no configuration, works. But if you want to customize the process, then you still can do so. But if you don't want to, then you can use the simple thing, and it should work and be secure. So the question is, can we actually replace OpenSSL with something like that? And I say yes, we can. And the solution to do this is actually using protocols. So we have protocols today that would allow us to do such things, that would allow us to implement an API like this. The problem is that they're just not commonly implemented. So Krypt has more advantages, not just this distinction between high-level and low-level API. For example, it has a lot more tests. So C is the traditional language for crypto libraries, and we all know that C is really hard to test. But this is something where Ruby usually shines. So besides having RSpec tests, a lot of them, we also have Fuzzbird, which is our own tool to do automatic fuzzing of the library. So we shoot random data at the library and see what happens. And the reason for this is if you look at today's vulnerabilities in OpenSSL or similar libraries, then it's often that they were found by somebody using a fuzzer, and then they detected a vulnerability. And so I thought, why don't we do this right away during development? and not wait for others to do it for us. This is also very important. I think a huge part of the success of projects like Rails or similar projects is that they actually have really good documentation. And I believe it's even more important for a security library, since there's a lot of things that can go wrong. There's a lot of things that are dangerous, so we need to tell our users. And I think this is something where pretty much every security library in existence fails today. And this is, something that is also pretty important. We use a lot more Ruby than existing libraries. For example, the OpenSSL extension is just merely a wrapper written in C around OpenSSL, the C library. In Crypt, we try to use as much Ruby as possible, since we believe that Ruby is much easier to read and understand, and it's also easier to maintain, since by using Ruby, we can't introduce new buffer overflows or things like that, because this is something that simply is abstracted away from us already. So while we probably can't abandon native code completely, we try to contain it as much as possible. And we use native code to wrap existing libraries in a common Crypt interface, but we only use this in the background, so it's never exposed to you. And what this allows us to do is it actually allows us to choose what we want to use in the background. This is not possible today. We're pretty much tied to OpenSSL if we want to use cryptography. But with an approach like Krypt does, you can actually choose what you want to use. You could choose OpenSSL if you want to, but you could also choose other crypto libraries. And the rest written on top of that is just plain Ruby. So why should anyone care about this? So is this just an ideological thing to use Ruby there, or does this actually give us advantages too? And I believe it does, since this approach allows us to achieve true platform interoperability. This is something that we don't have today, because we can actually write something that will run equally well on all Rubies. Now, you might say, I don't care. I'm not ever going to write crypto code, so why should I care if your stupid library works? And the answer is, while you probably will not write crypto code, what you eventually will do, and I think all of you will, is use HTTPS somehow. And I even go as far as claiming that if HTTPS doesn't work, then Ruby doesn't work. Sure, the language might still run, but the whole ecosystem collapses. Since if you want to do bundler or gems securely, you have to use HTTPS there to retrieve your gems. But if you don't have anything that gives you HTTPS, then you're pretty much screwed. So the problem is, to get HTTPS today, we use OpenSSL for this, which works but isn't available everywhere. So for example, Java doesn't have OpenSSL by default. Windows doesn't have OpenSSL by default, and OS X, Apple recently deprecated OpenSSL there, so it might not be available in the future as well. And I believe wrapping yet another library that is existing on those systems cannot be the answer, because we would just keep on doing the same mistakes over and over again, and it's just too much maintenance. And the only guarantee that we have with Ruby is that Ruby only can run Ruby code on all platforms. We don't have the same guarantee with native extensions, because they call for trouble. And I believe this is a huge part of why Java has been so successful, since pretty much every library, every extension to Java is written in Java itself. And so it will run on every platform that will run Java. And we try to do the same thing with Krypt. We try to concentrate on Ruby. We want to use as much Ruby as possible. Sure, we need some native parts in the background, but we want to interface with them using FFI and additionally using Java, and this will obviously just work for JRuby. But the focus is really on Ruby code. And using FFI is pretty neat because it allows us to use everything that works in MRI or Rubies directly on JRuby as well. And this opens interesting perspectives. For example, you could use OpenSSL, the C library, on JRuby, and you wouldn't have to change any of the code for this. You just change the underlying wiring of the gems, but your application code stays the same. And I have a demonstration for this. So let's make sure everybody can read this. It's okay. Can you guys in the background there see this?
Can you switch it to dark on
Invert? How do I do that? I don't know how to use one. Sorry? It's Linux. Okay, so I'll read it to you. Sorry, syntax light? Nope. Okay, I'm sorry. I'll publish the code too, so if you want to have a look. I'll try to read it to you. So what we do here is we instantiate a digest, SHA-1 digest. Then we inspect it, and we use it on a test value. So what I want to show to you here is that if we use this on Ruby, then the important thing here is what is used in the background to implement this. So you can't read it, but I'll try to explain. So it uses FFI to use OpenSSL in the background. So this is what it does by default on Rubies, on MRI, and every C-based Ruby. If we use the same code on JRuby now, then we'll see a different object being used. A native digest in this is something in Java, because by default on JRuby, we use the Java security library to implement Krypt. But if we want to use OpenSSL on JRuby as well, then we can do so by using the same application code. So this is the application code here. It stays the same, and all we need to change is instantiate another provider here that uses OpenSSL, and this will then wire up this OpenSSL provider also with JRuby. And if we execute this, then we'll have the same result as with MRI before. So we are using now this FFI provider from JRuby that interfaces with OpenSSL. And of course, I hope at least the result stays the same. And this whole provider thing is actually implemented on the Ruby level. So this is not a native interface. It's something that is exposed in Ruby itself. So if you wanted to, you could just write a whole provider in Ruby itself without using any native code at all. And this is because all of the interface is actually exposed in Ruby itself. So the details are not important here. It's just illustrating how you would implement your own digest provider in Ruby. And as you can see, there's no native code at all, and we can just run this on either Ruby or JRuby. It doesn't matter. So this was MRI, and this is JRuby. Same result, and it works. Okay, back to the presentation. So the thing to take home here is that you can run the same application code on whatever Ruby you're on. And it doesn't matter if you're on Windows, if you're on OS X, if you're on Linux. And it will use different things in the background to get there, but your application code will always stay the same. And this is what will give us true platform interoperability. In the future, since you saw we can actually use Ruby to implement providers, we also want to implement a provider just written in Ruby. And the reason for this is that we can say, well, if we can run Ruby anywhere, we can be sure that we can run Krypt there. And this is much like you're doing web development today. If you install Rails, if you don't do anything, then it will use WebRig in the background, and this will just work. But if you need something more sophisticated, something that is faster, then you would install a more sophisticated web server, and you have to do additional things to get there. And we want the same with Krypt. So if you install it, by default, it will use something that is written in Ruby, that is probably slow, but will work. And if you need something more sophisticated, then you can install something that uses a more sophisticated native library in the background. And yeah, of course, we took a look at other programming languages. How do they handle cryptography? And for C-based languages, we had much the same picture like we have for Ruby. So they did the same thing and implemented OpenSSL in their language, but this also means that they're tightly coupled to OpenSSL. And this also means they have the same problems as Ruby does. We don't have true platform interoperability. For Java-based languages, the picture is looks a little brighter. They're still tightly coupled to either Java security libraries or Bouncy Castle, but at least using Java means they have platform interoperability, but it also means they don't have access to C libraries by default, and it also means that they just have an expert API, so nothing that would be easy to use. So we thought, why not make their lives easier as well? Why not just make Krypt, besides being a Ruby library, also a C and a Java library? Since we already have parts written in those languages, we could actually do this. And Krypt could then serve as a blueprint for other languages to integrate Krypt in their language. And this would would give them the same advantages of platform interoperability and also high-level API access to C and so on. And yeah, the plan is to Krypt everywhere. And once we've actually accomplished our goal and taken over the crypto world, we'll at least be nice to you in this room. So what happens if this just stays an idea? So if nobody cares, nobody wants to pick it up, well, it will make us sad, of course, but I also think it will still be of advantage for us, because by restricting ourselves to stay as modular as possible, this will actually help our design, because if I learned anything in my career, then it's that coding to interfaces will actually improve your code. So we've talked a lot about Krypt. Now the question is it used anywhere? Is it any good? And we've had a few success stories so far. First of all, we were participating in Google's Summer of Code for JRuby last year and again this year. This year, even with 2 projects featuring Defrat and Matthew. And the biggest success story so far has been this. As of JRuby 1.7.3, they actually integrated Krypt in JRuby itself. And what we do there is we provide missing features that are available on MRI but not on JRuby. And so this was really huge for the project, and I want to thank Charles and Tom and the whole JRuby team for putting their faith in the project. And as you can imagine, we still have a lot to do, and there's still a lot just to work out. But we're positive, and the plan is to one day replace OpenSSL entirely and make Krypt the default crypto library for Ruby. Now, it's always hard to make the transition. If you have something new, then how do we get users to use the new thing? And we also have a plan there. This is what we currently already used in JRuby. There's an OpenSSL shim library that exposes the same interface as OpenSSL does. And it uses Krypt in the background to implement this. And this already exists. There's not much in there yet, but this is going to grow over time. And yes, we hope to one day actually expose the full feature set that OpenSSL does today. Okay, that's pretty much it. So thanks. And if you're interested in Crypt, have a look on GitHub. I wrote some blog articles on my blog if you're interested, and I'm sure more will follow. Write me an email if you want to, or yeah, ping me on Twitter. Thanks.